So next, we also do this fine-tuning test for the LLM. It shows really interesting, like different stages, even within this fine-tuning process. We can just basically decompose this process. Well, it is. I should highlight this. This is very algorithm determined behavior. So if you try different algorithm for fine tuning or even for the training, you will have a completely different power consumption somehow. Well, let's go back to this case. So for this fine tuning case, we decompose into 4 stages. The first stage is from 0 to 350 seconds. This is like the warm up of this whole fine tuning process. It involves like an initialization of the algorithm, the data load in, and also like the parameter initialization. This involves very little power consumption, as we can observe. And moving on to like a second stage, we can observe like the rapid change power consumption, like the peak, the surge and the dip about the power. This actually introduced by the evaluation intervals. This is the algorithm evaluate the performance of this model based on the fine-tuning dataset. And if we're moving a little bit like longer in the later half of this stage, we see like more like a steady behavior of the power consumption. So after this stage, the third stage, we reach to this very steady phase. In this phase, like the power consumption is really similar to the training stage, and the learning rate will enter this so-called decay phase. And we can observe like even in this fine-tuning stage, the second stage and the second phase and the third phase really exhibit totally different power behavior somehow. At the end, it's just a checkpoint and just shut down all the algorithm. So the power consumption go to 0 somehow. Not 0, like near 0, the idle power consumption.